Whenever we are working in Fusion, we should almost always be using a linear workflow. Let me explain to you what exactly that means, when we have to do it, when we can avoid it, what the reason for this is, and of course how we can set it up in Fusion. I'm covering this topic a lot in my compositing course as well, which you find on my website, but it's such a basic topic that I think everyone who is using Fusion should know about it, which is why I want to do something for YouTube as well. So let's have a look. Let's start out super simple by looking at a plain gradient, just a background node in Fusion where I say left black, white, right, and in between values. And if I look at this in the viewer, and I can open a second viewer and open a waveform monitor, view waveform. So the waveform shows me the brightness from left to right for the pixels in the image. So from left to right, I'm going from 0 to 1, or in this scale, it's actually going from 0 to 100. But inside Fusion, we have everything from 0 in the 0-1 range, 1 meaning white, 0 meaning black, and we have a linear curve. So far, that's easy, right? So what's so great about linear? Well, it's so easy in the real physical world, right? If I want to know how much light falls into the camera, let's say I have one single light bulb turned on, a certain amount of light falls into the camera, I turn on a second one, well, 2 times as much light falls into the camera. That's a linear relationship. Now, the only problem with this is, even though it's simple, our eyes don't work this way, our monitors don't work this way, film never work this way, and our camera sensors don't work this way. And there's a reason for this, and that's basically that we need to be able to deal with bright sunlight when we go outside. So the sun is like a million times brighter than everything else, so we still want to see everything else despite super bright sunlight, right? So that's why this encoding here, this linear encoding, is not very good for us in order to see details in the shadows, which we need if the sun is shining, right? So putting it very simple. And that's why our cameras don't encode this way, and monitors and sensors and film and so on work differently, and they have different types of adjustment curves. You have probably heard of gamma curve or of log curves. So let me use a gamut node, which is adding a gamma curve in this case. So if you want to see how our typical film footage would be encoded, if I create a clip for YouTube, then to this gradient as captured by the camera, we would apply such an adjustment curve, which says basically in the black range, put more data, use a larger range of data for the left part here. For the darker ranges, use more data in this area, and use less data, less latitude here in the right area. So that's what a gamma curve does. If you go for log footage, here is a log curve, then this is even more amplified, right? And there are different mathematical functions, logarithmic function, and here we have exponential functions in the gamma curve. I'm not going into the mathematics in this video, just keep in mind there is always an adjustment curve applied. Now in Fusion we can work with those adjustment curves, but we don't have to, and the luxury we have in Resolve and in Fusion is that we have much more bit depth than what your camera has. And to put it very simple, so your camera has 8, 10, 12 bit of data available per channel to record luminance information, but in Fusion or in DaVinci Resolve the default is 32 bit, and that just means that there's much more data available to save those lower shadow values and save out of range values and other stuff. And here the advantage is that we can remove those curves without losing any shadow detail inside Fusion or inside DaVinci Resolve. Well, what does this mean for working, right? For Fusion, for editing, for color grading? Well, it just means that some of the tools we are using need to be aware how the encoding is performed in order to function accurately. Let me show you an example, and I'll just use a very simple blur as an example here, and I apply it to this wonderful photograph here. So I have this photograph, and this is coming from the internet, so any JPEG photograph would be encoded with sRGB typically. It's a standard color space and gamma correction for photographs. And I can remove that curve here, remove the sRGB with a gamut node, and then you see it just looks darker. And I have these tools right now are doing nothing. There's a blur, which is doing nothing right now. And after that, I have again a gamma curve where I'm adding the gamma again. So what does that mean? So here in the first line, I can just apply a blur without doing anything, just directly, and can see what happens. And in the second line, I first remove the gamma correction that is applied. Then I apply my blur, and then I add the gamma correction. So effectively, I shouldn't be doing anything different, except that I am applying the blur on linear space, whereas here I'm applying it directly on the photo. Let me do a left and right comparison. So on the left side, we have the directly being applied in sRGB. On the right side, we have it applied on linear space. And let's see what happens. And you should see that on the right side, we are maintaining the luminance. On the left side, the image gets actually darker. So you see directly, even a simple blur, you see a difference between left and right. And this would get even stronger if I was, for example, directly working on log footage. Let's say we have log footage and I'm simulating it here with the Cineon tool. I can convert from linear to log. So I'm just doing that conversion here. And let me show you this version. So if I look at the log footage typically looks a bit flat, not a lot of contrast. And then I go through the same flow and we can again do a left-right comparison. So on the right side is my linearized version where I do the blur on linear, on the left on log, and you see the result is even stronger. So you see even a simple blur tool depends on this gamma correction. Why is that? Well, the blur interpolates pixels inside the blur node, and it needs to know how it does that. So when you blur something, every single pixel is kind of spread around to the other pixels, and for this it needs to understand what does it mean if a bright pixel has, say, 50% impact on a neighboring pixel or 30% impact. And for this, it's important to know, is it a linear curve or is any other curve being applied? And this is where it makes a difference. I can show you that even more drastically with this little academic example here. I am just showing you one line here on an 11 by 11 pixel grid, and you can see what is actually happening to the pixels in this. I have again a transformation. So in the first area, I can blur here, and let me bring it into the view. So I can blur one pixel out to the other pixel, so it's getting blurred out, and I can do the same after going, let's say, after removing the gamma curve, which is happening here. And you will see again, same blur, but this is the first result, and this is the second different result. So the pixels are being distributed differently depending on how the gray values are being understood, and they are impacted by this color conversion. And blur is not the only tool here. Basically, every tool that reinterpolates pixels from one position to a new one has this kind of impact. And this goes even for things like transforms and merges. Let me demonstrate. Just a simple transform. You think nothing can go wrong, right? So we have a transform, and let me rotate, and with a low pixel resolution, you see what's happening. So pixels are getting interpolated like onto the diagonals as I rotate. And this is if I rotate directly, but if I did the same in linear space, you see I get a different result, and in log, again, even a different result. Now, the differences may not always be as drastic as what I'm showing here right now, but you see there are differences, so we should know what our tools expect that we are using. And they are designed in Fusion to work in linear. Now, why is that? For example, in the DaVinci Resolve color space, you're not working in linear. You can work in Rec 709 or in ACES CCT, which is basically a logarithmic adjustment. So the color page tools in Resolve are not designed for linear, but in Fusion they are designed for linear. And the reason is just in compositing, Fusion has some 250 tools, and you can build your own tools, you can do your own scripting. So either you would have to demand that every single tool that was ever built for Fusion has to comply with every possible color space, or you have to make another assumption, and that is that you're working on linear, and you can easily enforce that by just bringing the footage to linear as you enter Fusion and bringing it back as you leave Fusion. So let me show you how I actually set this up, and I do it the manual way in DaVinci Resolve now, and there's also an automatic way just to show you here in the DaVinci Resolve project settings under color management. I have my color science set to DaVinci YRGB, which is a so-called display referred color science, color management, which is just a very fancy way of saying you are doing it yourself. You are responsible for doing the color management. Resolve is not doing anything for me right now. Then there are the color managed versions, DaVinci Color Managed and ACES, and I think I will dedicate a separate video to those. In those cases, DaVinci Resolve is doing the linearization for you in an automagical way, and there are some quirks to it which I should discuss separately, I think. So for now, the manual way, which is also great to understand what's actually happening. So DaVinci YRGB is my setting here, and let's say I bring anything into Fusion from the media pool or from the timeline, or it doesn't matter how I go to Fusion. Let's say I had the photograph before. Let's say I use this clip now. I don't even know what it is. Let's see. Oh, this one here, it's from a Blackmagic training video. Then I can add a gamut node afterwards, or I can add, for log footage, I can add the Cineon log tool. This one is actually log footage, so I would go for the Cineon log tool. And in that Cineon tool, I find here Blackmagic Film, and then I would have to remember what this was, what camera this was, and I don't remember. I'll just select one just to show you the effect. So you see that I am going from log, which is like the flat look, like low contrast. I'm going to linear, which typically looks very dark. And then I can do my compositing, whatever you want to do. I'm not doing anything now, just, for illustration, let's say I'm doing something, whatever it is. And then when I'm done, I can go back to my original version. I can just copy my Cineon log tool here and go back. Here I went from log to lin. And on the way back, I should go from lin to log. And if I haven't changed any other setting and just copied it, I'm going exactly back to where I started, right? So here I started, and let me go into two viewers again. Here I'm back to the same place where I started. And the Cineon log tool, this would be for log footage, and there are quite a few presets here for different cameras and so on. So this way you can manually convert log footage into linear footage and back. You could also do it directly on the media in node. So instead of putting the separate log tool, I could go into media in, and here I have source color space and source gamma space, and in this video I'm talking about gamma, so linear, non-linear, it's always gamma. So here I can choose log, and then I have the same tool basically. So this is the same tool as this Cineon tool, which I have available here. This is for log footage. For Rec 709 or sRGB or anything like this, you would use the gamut tool. So you have seen it before. Let me add it again, gamut. And it's also available. So if you go into the media in, let me use it here. Maybe I can go to space, gamma space, space. And then here I have the different gamma spaces. And this was, I think, a photograph. So I have the photograph sRGB. I can click here, remove curve, and you see it gets immediately darker. And then the media out does not have this kind of control. So if we have at the end a media out in Resolve, then for some reason it doesn't have this. but you can add the gamut node before, and that's basically why I'm showing you this. So I can add the gamut node if I want to go back to sRGB, I can, or if I go to Rec 709, which is most likely what I may be using for final delivery, or Rec 2020 or whatever it is, you have the options here. For Rec 709, just to mention it, there you see two different ones. There is a Rec 709 display and a Rec 709 scene. The scene one is the original Rec 709 definition. The display one is a slightly different variety, and I always forget which one it is. So if you have to do pure Rec 709, you have to do this. However, in DaVinci Resolve, many people use like Rec 709 Gamma 2.2 or Rec 709 Gamma 2.4. And what that is in DaVinci Resolve is the Rec 709 standard, which defines the color space, the gamut, as well as the gamma, and then they change the gamma curve, which in that case does not include a certain linear component of the gamma curve. Now that sounds probably super technical and so on, and it gets even more scary if I show you in Fusion 1 second how I would do that, but I believe it's the easiest way in Fusion. So if you want to use this Rec 709 Gamma 2.2 or Gamma 2.4 in the output space here, you can just go to Custom, and Custom will by default give you sRGB, which has the same color space as Rec 709, but different settings for gamma. So there are chromaticities, which define like this triangle here, which defines the space for the RGB values, loosely speaking. And then there's a definition how this brightness adjustment is being performed. And the default in custom is for sRGB, but if I remove that limit here, then I have exactly what DaVinci Resolve in other pages calls Rec 709 Gamma 2.4. So the default definition of Rec 709 and the definition of sRGB, they have a certain linear component, so the curve starts in a linear way and then there's an exponential curve. Again, forget the mathematics, just to say there is this component in the standard definition, but if you use this Rec 709 Gamma 2.2, Gamma 2.4, one way to get this Gamma 2.6, whatever, is to put the linear limit to 0 and then enter whatever gamma you want, 2.2, 2.4, 2.6, so that would all be possible just by changing this gamma here. Okay, so I think this is the easiest way to set this. There are other tools in DaVinci Resolve. Let me show them to you. So in DaVinci Resolve, and this is not available in Fusion Studio, this is a Resolve effect in DaVinci Resolve. You have from the OpenFX tools, you have the OpenFX color tools, and you have here a color space transform. So this is an effect from the Resolve color page. And here you have input and output color space, you have here use timeline and so on. So basically you can control the gamma separately here, and here you have the same definitions that you see in other areas of DaVinci Resolve. So if you want to use Rec 709 Gamma 2.4, you can do that here, and actually you have here Rec 709, so you can set that separately here. Now the problem is with this tool, this is more aligned to what you see in other areas of DaVinci Resolve. The downside is this is, first of all, it's not available here in the media in or in the loader nodes, so you would always have to add this tool manually. That's maybe not the biggest problem, but there's another thing, and this comes to viewing the image. I showed you how I can transform the image, but actually I also want to see it, right? And once I remove my gamma curve, it looks dark. So the solution for this is to turn on a viewer LUT in Fusion. And the way you do this is you go on the LUT symbol. If you go onto this triangle, you can select different ones, and you almost always want the gamut view LUT, which I already have selected, and then you activate it, and then it is applying a LUT, and in my case it already looks the way it should look, and that's probably because of my default settings for this gamut view LUT, but you can check and go here on edit And what you have here is again basically the gamut node being applied in the viewer to whatever you are showing in the viewer. And here I'm just saying, well, source space nothing, do nothing, and output space add gamma add sRGB, because my monitor, like most computer monitors, works with sRGB, so calibrated to sRGB. And this way I have, whenever I have my LUT turned on, I am looking at the image in sRGB. If you have calibrated your monitor to Rec 709, for example, you could do that as well. Could find the correct setting here, Rec 709 scene, or even go to this custom and this way turn the linear limit off and do a Rec 709 gamma 2.4 or gamma 2.2. So you could do this directly here in the gamut view LUT. Once you do this, you probably want to right click here and save your settings, save default, so that the gamut view is always doing the same thing when you're turning it on. So there we have the simple workflow. So you bring your footage, whatever it is, into linear, do your compositing, and then bring it back or bring it towards your final output, depending on what your next steps are. So in DaVinci Resolve, typically you come from the timeline and you want to send it back the same way. So if you have log footage in the timeline, you bring it to linear, but then you bring it back into log footage, and then you do the final color grading, etc. at the very end. In other cases, determine the individual sources and bring them all to linear, so you have a common basis. So photograph, JPEG, most likely sRGB, stock footage, most likely Rec 709, camera footage, in many cases log footage, ARRI logs, Canon log, etc., etc. So you can set it up this way. Do you always have to work in linear? Well, no, it's generally a safe assumption, but there are a few cases where you may not want to work in linear. If you are only doing color corrections, then you are not causing any harm if you're not working in linear. For example, if you only do, let's say you do a gamma a curve correction, let's say you bring in color curves here, those curves are not different than the gamma curve that is applied before. So if I use that in linear or if I use that in sRGB, the curves tool will behave differently. Same with brightness and contrast or with color corrections. But as long as I use only color correction tools, they will behave differently, but you will not be causing any mathematical error in the compositing. If you know that the tools behave differently, you adjust them differently, the values, the parameter values will look differently, but you're not causing any error. But that also means that if you want to, if you prefer to work in sRGB or in Rec 709 because you're used to color grading in Rec 709, and you may find it convenient to do so, and you can do so. So whether it's a curves tool or a color corrector, you can bring your footage into Rec 709, do your color correction, bring it back, if you find the tools more convenient to use that way. It's really just about how the tool reacts to the footage, how convenient it is to use it. Another area might be green screen. So in principle, you can do keying on linear footage, but sometimes you may observe that the matte separation may work better after some pre-processing. So when you use the delta keyer or a luma keyer, in some cases that separation between background and foreground may come out better if you are working in nonlinear. So that's definitely something that you can try. Generally the tools work fine in linear, but if you're only doing the green screen extraction and you're not doing any scaling and any more other compositing tasks, you only do the calculation of the alpha channel, then you can also do that in other color spaces. And if you get a better result from doing it in Rec 709, for example, if you get a cleaner alpha channel, there's nothing wrong with using that. Okay, that was a lot of information, but it's not too complicated. At the end, there are like 3 tools: the gamut node, the Cineon log tool, and in DaVinci Resolve, the Resolve color space transform tool. And if you apply those, find the correct settings for your camera, you can easily set up a linear workflow manually, go back afterwards, determine your viewer LUT, most likely sRGB for most monitors for viewing, and with that you should be set. What's left is Resolve color management and ACES and that's a topic for another day. Thanks for watching.
It's us.